Here with GemTalk Systems, and we're going to give you a brief introduction to Gemstone and then a product roadmap. So first, what is Gemstone? Some of this will be familiar to some of you, but I want to take every opportunity I can to pitch Smalltalk, and when we have students and conferences, I'll put in some of that. Smalltalk is a programming environment, not merely a language. We discussed a little bit of this at lunch with some of you, that it's not simply message sends, but the tools that are built around it. And we have an object space and a virtual machine, and then the representation on disk. It's an all-inclusive environment where you open an image and step into a magical world, and you modify that world. So we don't so much build up as step in and modify with the tools contained there. Everything is an object, and there's a powerful class library that goes with it. Traditional Smalltalks, the object space must fit into RAM, virtual RAM at least, and the object space is visible in only one virtual machine. Sharing objects between virtual machines involves exporting them, importing them, and that doesn't have a consistent identity with it. So typically if you export something then import it, it will have a new identity. And if the virtual machine exits, you haven't saved the image, you lose the state. These are ways that Gemstone is different. The object space is limited by disk rather than RAM. The object space is shared across multiple virtual machines with multiple hosts. And there is transactional persistence, so that each time a transaction commits, the data is saved and not lost, even if the virtual machine quits. Multi-user system, programmable, a whole series of characteristics. Scalable, thousands of concurrent users, sessions. Virtual machines can be on hundreds of hosts. The object space is terabytes in size and thousands of transactions per second, with 1 trillion objects total is the current design limit. Concurrency, multiple sessions can be active. Each user can have multiple sessions, and each login session can have a different namespace and namespaces. Changes to objects are transaction-based. So when you have a commit, then they can be visible to others. Otherwise, they're isolated. Concurrency checks are available, locks for coordination. So we can coordinate concurrency and so on. User-based security, logins require a password to get into the database. Namespaces can at least make objects less visible. System operations can require particular permission. So to do a backup or to change passwords, you have to have certain permissions, authorities. And then there is a per-object security. So each object can be designated as being readable and or writable to an individual user, to groups of users, or to the world. So, security. Smalltalk is the data definition, object manipulation, query, concurrency management, system management is all done through Smalltalk. So directly there. You can do the client-server partitioning. Gemstone provides a C interface, and we were talking with some people about the possibility then of if you can bind to a shared library, a DLL or a .so, then you can start interacting with Gemstone. There's an API in the C library to log in, manipulate objects, and send messages. There's a Java library that can load into your Java environment. There's a Smalltalk library that can load into Visual Age and Visual Works, or VA Smalltalk from instantiations, and Syncom Smalltalk. And that is the way most of our clients, most of our existing customers are using that model, doing the rich client in the client Smalltalk and then using Gemstone on the back end for persistence. So object space must fit in RAM, again traditional, visible to only one VM, sharing, and with a large-scale object space, you're limited only by the size of the disk, though we do cache in memory for performance. Object space is shared by all connected sessions, and the view is based on the last commit or abort. Persistence by reachability from a root object, so again, garbage collection is handled. All you need to do to make something persistent rather than some sort of save operation is just attach it to a persistent root and then commit. So add a new customer object to a customer collection and commit, and it is now persistent. Database views are isolated with repeatable reads. So changes that you make before you do a commit are not visible to others but will still be visible to you. Changes other people make are not visible to you until they commit and you do a commit or abort. System management is available, again, through Smalltalk messages, online backups, restoring trend logs. So again, you won't lose work, traditional database things. You can add and remove hosts to a running system. So if you want to extend your system, scaling it up, monitoring it for performance. So that's a brief introduction to Gemstone. We'll look at a few other items here. Gemstone is part of GemTalk now. Gemstone as a project, and some of the people on the project have been around for over 30 years. Been through various companies, and I know that some of you have been through similar experiences, particularly in the Smalltalk vendor market. We're each on our second, third, fourth permutation. So that's happening here as well. We are now 1 year old, and some of the things that have come out during this year is version 3.2, which we will discuss, and version 3.3, which we expect to come out with next year. So 3.2, what's new since we were here last year? Lots of work with Unicode, which again, for those in the non-American, North American environment, you want language support. So Unicode is now supported quite thoroughly with indexing. We use the ICU collators and are using the libicu functionality. Indexing, again, when you have a large amount of data, you can't just iterate over it and look at each object in a collection and have that perform well if you have millions of objects. We have indexes that allow fast access through B-tree type structures. We are now supporting set valued path terms where your index can step through a collection, a set. And so if you have customers, a customer list, and customers have multiple addresses, you can index on the city and just say, give me all the customers that have an address that includes this city. There's a new query API. Part of the query API is intended to be more traditional ANSI Smalltalk communication, so that rather than having a special syntax for queries, we now have an API. This allows you to write code and port it from Gemstone back and forth to other Smalltalks. Index creation, selector path terms, date and date time are now encoded in the B trees. So if you're doing a date search, index search, we can actually find the begin and end range without having to load the objects into memory. we can just examine the B trees and get to the first and last one and then create a new collection that gives you everything in this range without actually bringing the object in and having to send in a message to ask for its state. Unicode indexes. Gemstone now has a hot standby feature where you can have a second database running, connect the two, and transactions, each commit will get sent to the second system as it is applied on the first system. And the second system can be brought up and brought up to date. If it goes offline, when it comes back online, the transactions that it's missing will get sent to it. So typically we have customers that use something like this for having a second database in a second data center. And so their redundancy is such that if an entire data center goes out, they have up until a recent transaction already transmitted to the second data center. And since that's going over a broader network, we can use secure sockets so that the data is actually encrypted as it goes there. The C library up until 3.2 was single-threaded, so you could only have one call into the C library at a time. We have a new preview of a multi-threaded C library. So you can have connections, multiple connections that you're managing either to the same database or to multiple databases. Start an operation in one session, start another operation in a second session, look for the results on one or the other. And we've been waiting for VisualWorks 64-bit and now have a good solid base there, and we're allowing 64-bit Windows clients to interact with our system as well. As memory gets more available, people are using more and more memory, and large memory segments. When you're allocating a gigabyte or multiple gigabytes, I think one of our customers has a 2 terabyte machine and has 1 terabyte for the database cache. And if you're allocating those in 4K chunks, it creates lots of overhead for the operating system. And so there's large page support for AIX and Linux that require certain things, more monitoring tools. One of the things that we do, of course, with a large object space is garbage collection gets quite a bit more complicated. We do need to keep track of not only the objects that are no longer referenced, but different versions of objects. And so one session or login will have a view of the database that sees the object with certain attributes. A different login session will see the same object identity, but with different attributes. So it's the same object, but different versions of the object. To handle that, we need to do some complexity in garbage collection. Previously, and again, this dates from architecture that's 20, 30 years old, is we have lots of processes running when you're running a Gemstone system. There are many processes. We are moving to threads in more of our activities. And so now, previous to 3.2, there would be multiple processes. Now we have one thread. Now we have one process with multiple threads. And each one can log in as a separate session and do garbage collection activity. So this is improving performance. One of the things that can happen is this garbage collection actually is, the purpose of garbage collection, of course, is to make free space available. But in order to do that, if you have objects that are on one page, other objects that are on another page, and each page is only half full, you can reduce the space that they take by combining the objects onto a third page, so that now you are only using one page to hold these objects instead of two. The disadvantage of that is that during the transition, you actually are using a total of 3 pages, where previously you were using only 2 pages. And this can cause, so attempting to make the database smaller can actually make it quite a bit bigger. And I don't know if our friends at Telecom remember, but a year ago, when we went up on 64-bit, the garbage collection went so much faster that instead of taking several days to scan the entire database, in a couple hours. So we installed it, got everything up, went out to lunch. When we came back, the database size had doubled. And it was causing lots of alarms to go off in the system admin place. And yes, excitement. But so we actually have a new feature that says, stop that garbage collection activity if space gets low. It will keep everybody a lot happier. As it happens, as long as you have disk space, then, the extents grew. By the time the garbage collection finished, there was lots and lots of free space, and there are strategies for recovering it. So it was more just a matter of, we have never seen garbage collection go so fast. And it turns out, yes, it did, that it had this intermediate stage where there was duplicates of everything. One of the things in a large database is finding objects that have certain characteristics. I have lots of objects. I know that there's lots more of these than I think there should be. Who's referencing them? Why is this not getting garbage collected? And so we have methods list references to instances of classes. So you can say, find not just all the instances of this particular class, but find me everyone that references an instance of this particular class. Something like that is particularly helpful for changing the references to being immediates. And so in older versions of Gemstone, floating point numbers were real objects that took up real space in the database. We now have something called a small float that can take 61 bits, and if a floating point number can be stored in 61 bits, we will store it directly in the object ID, which is what other Smalltalks are doing similar things. And in fact, we even coordinated our implementation of small float with Syncom so that we can copy the small float back and forth. A small int has the same model. So there's large integers that are real objects that take up space. Then there's small integers that fit within the object ID. Likewise, there's large floats and small floats. And we'll come later in 3.3, we actually are giving you the option of putting fractions inside an object ID. In Gemstone, previous to 3.2, we had a perform on server. Now we have an asynchronous one where you can actually start up a separate process, connect to it with sockets, essentially sockets, so you can capture standard in, standard out, and then feed things to standard in, look at the result from standard out. So you can control this remote process asynchronously. Some of our customers, banks, JP Morgan, for example, wants to have lots of audit trails. Everybody who logs in, we need to keep a record of it. So we have some logging capability, capture timestamps, what they did, session ID, process ID, Unix ID, what the client IP was, and so on. So there's a file that you can look at. Find reference paths. Why is this object still referenced? Starting from the root, what is the path? What are all the paths that find this object? So, for example, L at the bottom here is referenced from the root through 3 different paths. There's one message you can send that says, give me an array of arrays of the path that leads to this object, so better understand my reference path. Multi-threaded operations, there's various things that scan the database, and now we have multiple threads that work on different parts of the database at the same time, and this allows us much better performance. There's some customers, again I mentioned, who are going to the trouble to have the entire database loaded in memory, and Gemstone obviously is designed for caching some of the database in memory, but we go through a certain process of looking to see if the thing we want is already there. And there's an optimization we can do if we're sure that it is there, where we don't have to spend as much time looking in different places. So certain operations are faster with the entire database in memory with this configuration. One of the things that we've experienced over 30 years of Gemstone is the growth from kilobytes to megabytes to gigabytes. And so it used to be that when you defined your sizes of the extents, or the size of the private page cache, or the shared page cache, is defined in kilobytes. Well, that gets a bit cumbersome when you have to keep adding zeros on and you're not sure how many zeros you've added. And so there's a number of these now that just, you can put a number with a suffix. And so if you want a 2 gigabyte shared page cache, you don't have to say 2 times 1024 times 1024 and try to write out this million number. Pre-growing, some of you work with pre-grow. Make the extents a certain size. You can actually have a minimum as well as a maximum now. And NFS is something that historically we have found to be somewhat unreliable, particularly when it comes to locking and flushing. And so we have historically said you cannot use NFS for the database. There's some instances where people want to use it and are willing to take the risk, and so we will recommend against it but allow it. Shared counters, some things that you want to be able to do for getting customer IDs or purchase orders or something like that, you need a unique ID. And in a transactional database, you'd have to lock the counter, read it, increment it, write it back out, commit the transaction, unlock, and then you'd have a unique ID. Here what we have is a feature of persistent shared counters with a range of large range, and they're updated immediately even if your transaction does not commit. So simultaneous, someone can get a counter, someone else can get another counter, and this allows some unique serial numbers and good capabilities in certain situations. We support some new Ldap features. You can provide authentication for Ldap even if you're just looking up a name. We have a version of GemBuilder for the Android. And so you can connect from Android using the Java tools to get to the database. And so, for example, we have a test app where you give it some configuration, an IP address, port, stone name, user ID, password, click the login button, and then you have 4 buttons here: abort, commit, log out, and execute. You can type smalltalk code and click execute, and it will give you the result here. So this is, a little bit more of a proof of concept. We have at least one customer who's playing with it. This is, one of the skunkworks projects of, I don't know, do you think anyone would use this? So, well, give it a try. It's out there. You can download the test app, and if you have questions, contact Bill. But we think it's an interesting project. Statistics analysis has a number of enhancements, support 64-bit, faster loading, Session ID is in its own column. The mouse wheel scrolling. Windows 7 now has its own version that works properly for those of you who have played with visual statistics. We support lots of operating systems, versions of VisualWorks, versions of VA, Smalltalk. 3.3 has a faster virtual machine. Code generation now does branch prediction. We have small fraction, and so you store it into the object ID, and that takes up less space, fewer objects in your database, and faster evaluations. Translog restore has had quite a bit of performance improvements. You can write to the system log in Unix. We are switching over to LZ4 compression. Previously, everything up until now has been with zlib. We find that LZ4 is quite a bit faster, uses much less CPU to do compression. So we think that's going to give a good performance boost. We are now encrypting over certain areas that people want to be able to send it over a more public network or and have tighter encryption. Again, some of the banks that have had hacking and other things, they are now on a security encryption bandwagon, so we're supporting that. 3.3, things we're thinking about: native XML, passwordless login, delays, indexing, possibly this context, and we're looking for suggestions. New licensing options. Well, they're licensing perpetual, annual subscription, VAR with a percentage of royalties. So if you're building a project, you can look at that option. There's a website with some prices. We ship a key file for free that you don't have to give us any information. You can just download it and start using it. We have a limited one where all we ask for is an email, and then we'll provide higher limits. And then if you want the full subscription, you can get these configuration. You can increase the memory, increase the CPU, and so on. So this is again aimed at the low-end starter model. We're going to need people to graduate from that into the enterprise, but we want your startup to start out and get going with that. Other projects you may have heard about is Dale has done quite a bit in the Pharo community, Metacello. Much of that is to try to make it easy to migrate from Pharo to Gemstone. Now he's doing some source code management with Git, and he has Toad that he has shown at previous conferences, and that is his object development environment, Toad. I have a couple skunkwork projects that I've worked on off and on. I have a tool that runs on the Mac that will start and stop Gemstone databases, download them, take care of things there, and then a Windows IDE that allows you to work directly with the database without having to have client Smalltalk. So that is the presentation. Any quick questions, or we let people? And whoever's up next may want to go ahead and just get started if you'd like while questions are coming. Yes?
Today there's a lot of people talking about big data.
Yes. Okay, big data. That's the current buzzword. Yes.
But it's here to stay, I think. Do you have from customers using data?
Okay.
I know you have customers with lots of data.
Yes. Big data is probably a step beyond what we would be doing. We're more viewing ourselves as competing with something that you would do otherwise with Oracle, not with Hadoop. Yeah. So we aren't so much competing with Hadoop as we are with Oracle in that sense. But we're working, someone, for example, is extracting data from Hadoop and then bringing it into Gemstone and analyzing it there, because the analysis capabilities, if you could use Smalltalk or Ruby or something like that.
But then, how many objects does a big customer of yours have?
Many, I mean, the 32-bit limit was 1 billion objects. And part of the impetus for the 64-bit project was to get beyond that limit. Because people were hitting it, yes. So I don't know that, I haven't done actual object counts, but I don't know that they've gone much more than an order of magnitude beyond. Yeah, so, well, 10 maybe. Yeah. Not double, but order of magnitude multiplied by 10. I think there may be some that are in that range. When we went to 64-bit, rather than having 30 or 31 bits for the object, 30 bits is 1 billion. Rather than going, we allowed 40 bits for the object ID, which allows us 1 trillion objects, and that's still only 40 bits out of 64 bits. So we could go further, but I don't see that becoming a problem very quickly. Okay, I'm going to hand over the respective microphones.